All right, Unit 11, Lesson 3, Systems of Equations by Elimination. This is going to be the same strategy, same type of answer. Okay, so our goal for elimination is to eliminate or get rid of, which means cancel, either x or the y terms. You get to pick. All right. So some of the steps, it sounds really complicated, but most students actually enjoy this strategy. So step number 1 is you have to choose. You choose either x or y to eliminate, but you need to decide from the very beginning, eliminate. Okay. So step number 2, you need to determine there's going to be two coefficients. You need to determine the number that both coefficients will divide into. So you need to determine, we're going to call it the common multiple of those coefficients. Okay? Coefficients. One is going to be positive, one is going to be negative. All right? So you need to add both equations together. Then we're going to solve for one letter, whichever letter you have, and then we need to substitute our known value into either equation to get the other one. Because remember, our answer is a solution. So the student work will look different because there's lots of options for the common multiple, which variable you eliminate. But let's look at our first example. So if I look at 2x minus y equals 12, 2x minus 6y equals 2. You want your letters on the same side. So we're not going to move anything. You want them lined up because we're going to be adding them together. So you get to pick if I want x to eliminate or if I want y. They're both equally difficult. I'm just going to pick x, okay? Just because. So now I need to look. I've got 2 and 2, and I need a number that they both go into. So what I want, I have to come up with this. Well, I want one of them to be 2, and I want the other one to be negative 2, okay? So you need to figure out, what do we multiply by? Well, we don't need to do anything here because we're just going to multiply by 1. And here, I'm going to have to multiply by a negative 1. Remember, if you do it to one term, you have to do it to all terms. So I'm going to get 2x minus y equals 12, and negative 2x plus 6y equals negative 2. Okay, so I determined that, and this is how I get it. So then I'm going to add both equations together. So those cancel. 6 minus 1 is 5, and 12 minus 2 is 10. So then I'm going to divide by 5, and y equals 2. So now I can take that y and I can plug it into either equation. So 2x minus ry equals 12. I'm going to add 2, divide by 2. So we get 7, 2. Is our ordered pair. That's it. So let's do our second example. Same thing. You get to pick. Do you want the x's to go away or the y's? I'm just going to pick x's. So what do I want? Well, I've got negative 1 and negative 5. So I can keep one of them as negative 5, and I have to make the other one a positive 5. They have to be opposite numbers. So this can stay, but I need to multiply to get 5. I need to multiply by a negative 5, all terms. So we get 5x plus 15y equals negative 25. The bottom equation is going to stay the same. Then we're going to add them together. So we do cancel 15 minus 9. And negative 25 plus 7, divide by 6, So then I'll take that y value and substitute it into either original equation. So negative x plus 9 equals 5. Negative x equals subtract 9. Divide by negative 1. So 4, negative 3. All right, let's look at example 3. Same idea, pick x or y. I'll pick y. So if I have 2, I can make that a negative 2, and that's what we'll multiply by. So we get negative 2y plus 6x equals 10. I don't want to change the bottom. So those cancel, I get nothing. And 10 minus 10, those also cancel. So remember, once your letters cancel, you see, is this true or is this false? Since this is true, that means that these are actually the same line disguised. So it's going to be infinitely many solutions. Okay? If that was false, we would say no solution. So let's look at our last example. I've got 2, 3. Let's notice these are not lined up, so I'm going to. Okay. So we get to pick. I'll just go ahead and pick y. So I'm going to multiply everything by negative 3 because I want, this is positive 3. So we get 3. We'll add those together. Add those. And so now that all my variables go away, this is false, which means these lines never intersect. They're actually parallel.